Alrighty. I think we're recording everywhere we need to be recording.
Excellent.
So this is part 3 of our journey through clay. Journey to the center of clay. We talked about data structures. And then last time we talked about reading from clay, reading any individual piece of data at either the current time or sometime in the past, or we had ways to express something in the future, but we didn't show any way of being able to fill such a request. And so this time we're going to talk about subscriptions, which basically, which is going to take the same kind of requests we were making in the last episode and extending them throughout time. So you can make a request for something that doesn't exist yet, or for a version which doesn't exist yet. There's a few other ways that you make something that that is a request that's going to be answered in the future. That's kind of the way we think of a subscription here. Is not necessarily a stream of updates. It's very often just a request for something in the future that we'll hold on to and give a response as soon as it exists, if it ever does. Yeah. So we touched on this a little bit in the data structures episode, but the model here is that we always fill subscriptions out of our current state. So we never do it like edge triggered. We never do it because you wrote this. Someone, you're requesting to write this file. Someone was subscribed on that, so they get the update. We don't structure it that way. We put this firewall in between where we say, you wrote this file. Okay, that means it changed the state. Separately, the state has changed, and so let me see if I can fill any subscriptions that I couldn't before. And so the way that happens in practice is that wake gets called in a bunch of places. And you can see it's like, it happens. This is anytime a reset happens. We're like, okay, do whatever you're going to do, and then just call wake. That's if you get a timer result from, from Bane, call wake. This is in Park. So this is anytime you write a commit, very last thing you do is run wake. I guess those are the only real times, that's the only time it's structured that way. So there's also this. If you change permissions, you run wake, because maybe you made it so now they can read something they couldn't read before. Maybe someone can get a result from that, or the reverse, right? You're waiting on something you have permission for. Now you don't have permission, so now you should get a negative response. This is another place where you need to do it. If you get a response from a foreign ship, you're going to put that in your state and then call wake, so that if anyone was waiting on that, they get the answer. And so the rule for when you can call wake is you can always call wake. The rule for when you need to call wake is anytime that you changed the state in such a way that a subscription might become, might be filled. The worst case, if you don't call wake, is that nobody's going to get an answer until someone else happens to call wake. Happens to call wake on that desk, because the list of subscriptions is per desk, I believe. Yeah, it is. If you remember the list
So in practice, that means you have to call wake. Whenever you change any state on the desk, right?
Pretty much. You don't have to call it if you tombstoned a file or something, or
yeah. Right. So there are a couple exceptions where you don't. I guess I'm a little surprised that
if you
this doesn't actually follow the pattern.
Go ahead.
I'm a little surprised that this isn't just an abet pattern, actually. right? Like where,
Yeah,
every
it
time
really could
we,
be in a bet. The it's a little bit slow in theory. In practice, it's not that slow. There were times when it wasn't, like when it was much slower than it is now. Um, it would be reasonable to put it in a bet.
yeah,
Like,
especially since it's like anytime we're taking changes, really, right? Like if, yeah,
yeah, I mean, you kind of don't want all your warps to be calling it, but eh. You would just call it like a few too many times, and as we'll see, it's not a super slow operation, but it's also not super fast. Um,
yeah. I guess if it's only called in a few places, it's fine to just do it manually and just don't mess it up. Yeah.
yeah, we have messed it up in the past, but it's been a long time. Yeah. All right. So the main data structure that it operates on is cult, which we looked at before, which is a jug. So a map of wove, which is a request, to duct, which is the requester. Um, and we will look into that in a lot of specificity. So let's take a look at wake.
All right.
So we produce a copy of this core that we're in. So wake doesn't take any arguments, but it is inside the desk core, so it's specific to a desk. We're gonna loop through our subscriptions, and we're gonna produce a new set of subscriptions. So this is always gonna. So this is the old one, which doesn't get referenced anymore, except that we'd overwrite it. You actually could do it with tis.dot, but it'd be confusing. I don't know if it's more confusing than this, but yeah, the structure there is we're building up a new set of subscriptions that'll mostly be the same as the old set of subscriptions, but potentially have some fewer, potentially some modified subscriptions, or at least subscription state. And so so we loop through. We say if we're looking at a subscription that has no subscribers because for whatever reason it got removed, the last one got removed, then we recurse. Since we didn't put it into, there's a affirmative consent principle here. Since we didn't put it into Quux, then it's not there, so it got deleted.
Isn't
Yeah.
this a little weird that that there could be no ducts for a subscription? Like, why don't we just delete it?
Well, let's see. So cancel request gets called. I think this is the one. Yeah. So if someone sends us a warp with a null as the request, then that means cancel whatever this duct was sending or what was requesting, and that goes through. And does not do exactly what I expected, but what does rep mean?
So,
Hmm?
Rep by, it's sort of like run by, right? But I think it takes in, like, was it key and value?
No, that's earn by. Rep by builds up a it builds up an accumulator, I think, right?
I don't
Oh,
remember. I'll look it up.
yeah. Okay, so from reading this and the output, this is saying delete this from every item in the subscription map, and this is producing a list of wove. So I assume that that's saying that this is saying basically, like we're accumulating this list of wove by adding to it only if
Only if it has
it's in there.
the,
Right. If has is okay, this is like when it's a single line, this kind of thing should always be like unless is much harder to think about than this.
Yeah.
So if it's in B, so if this duct is making this request that we're looking at, then put it in the list. Otherwise, don't. So we're getting a list of all the requests this duct has made. That's what's here. This is that we're deleting this duct from all the possible requests. I don't know why we need this list. It turns out we only need this list if it's a
Run a future.
so what sigref means it's a local desk, like a domestic desk, and then we say
Loop through these. Right? So for each one, we call run a future.
right, which means basically we're gonna end up run a future we're gonna end up looking at today anyway, so we can take a look at it now. Let me make sure I understand this. So fire function if request is in the future. So we're given a request and we're given a function. We start looking at the request and say approximately if it's in the future, which is wow, this is confusing. So if it's a next request, we don't do answer. If it's a multi request, which is similar to next request, we don't do anything. If it's a many request, oh gosh, hunt. I think I remember that one.
Yeah, this looks like we're just extracting the pat DA from a case that's in the request.
Yeah.
I think that's what all this. Yeah,
Right.
and so basically, sometimes we can do that, and sometimes we can't. If we can't do that, then this produces sig. But if we can, then we get a case. So the simple case is on like 3238, where we have a case in the mood of the rov, and that case is a SNDA, and so it's a date case, and so we can actually extract that.
Right, but weirdly,
we can also move the date up to now, I guess.
Okay, let me try to
or maybe move it from now to like something. Presumably to the future.
Let me remember what hunt is, and this will be a little easier to remember. First of units. Okay, so wow.
It's hard to read.
Way more abstract.
Like, yeah, code.
Right. Fall, bind, hunt. It's like, yeah, this should just be what's
it's hard to read. Somebody wrote some Haskell in this hoon. It's hard to read.
Yeah, who would do such a thing? It's definitely me. But it was a learning process, and I never wrote it again. Maybe. Okay, so basically, we're trying to get some sense of, if what is coming from has a date, then if now is less than that date, if that date is in the future, then produce that date. Otherwise, if what we're going to is in the future, produce that date or now, sort of, for some reason.
It's just if the other one is we're not checking whether it's from the future. We're just
we're doing max of now in it.
Right. Yeah. So we're just taking whichever one's left.
Yeah. Yeah.
So it's only for the start date that we're checking whether it's future.
Right.
And then for the end date, it's just either if we're supposed to end in the past, then we bump that forward to now. Otherwise, we just keep it to whatever date it was.
Right. It is very strange that we're calling it here. I think there's another call site that is going to make some more sense. Oh, okay. That would help some. So we set timers for stuff, And what we're basically trying to do is say,
we're trying to figure out when we set the timer so that we can cancel it.
yeah. We probably don't even get this right, and the timer will just go off and it's fine, because it really is fine. It doesn't make that big of a difference, but there's the
what is it like? Where are we called best? I forgot.
So run a future. So this is where so we're canceling a request.
Yeah.
And we're saying for each of those requests, try and get what time that we would have scheduled to wake it up.
Right. Yeah.
Right. What it really should be, if we want it to be like precise about our timers, is just like store whether you set a timer and what time you set it at, and then just check that. I think rather than trying to rederive it, feels.
Well, this would also be a lot cleaner if we just separated it into two different functions. One that's like find, date, like wake up date, right, which produces unit pat da, right? Just this inner part of the function, right? You give it a rove,
right,
and it's like,
well, this one,
grab the wake up. Yeah, right. Like, because then it's clear what it's doing. It's like, okay, yeah, there are a couple different cases here. You may or may not be able to extract this. And then there's this run of future, which like, finds that date and then like, massages it, or like checks whether it's greater than now, right? And if it is, then, then we fire the function, and if not, then right. And I think that like just splitting it up into two pieces, it would be a lot less confusing.
Yeah. Maybe basically.
Yeah, you could just do it in like that. Yeah.
Doing that and then saying, okay, what sig date, lusgar.buck,
right.
Otherwise call fun with u.date. That basically is at least, is already somewhat simpler. Hunt should be split up further.
And I'm not sure it's actually u.date. I think it might be, we actually check whether the date is greater than now, right? Or less than now, something like that.
Where?
Oh, I don't know. I was just thinking like the date that comes out of that might be less than now, in which case we still don't want to call the function.
Right? Well, we might still have a timer out for it. I don't know. I think that...
Yeah, but we don't want to actually but in run a future, we don't want to fire the fun, because we're not supposed to fire fun unless the date is in the future.
Well, right? It says run a future, but I think it's more like run if we might have a timer set for it. Let me find the other call sign.
But if that date is in the past, then presumably we won't have a timer set for it, or like it's unlikely that we will, because the timer will have probably fired.
I think what it's really doing is saying, so in our requests, I believe that we rewrite our requests from dates to eons as soon as we know what the eon is. And so in theory, if we have a date for a signal request, or a date as the from or to of a many request, that means that we must have set a timer to wait until that date to wake up for that eon. Because if we've already woken up for it, then we would have rewritten it from send-da to a send-ud, like to an eon directly. And so the claim seems to be any dates we have, we're going to want to cancel maybe now instead. That probably worked with a previous version of Bane and doesn't work with today's or something. I don't know. Or maybe there's just something I need to think harder about.
Right, it wouldn't work. It doesn't work with today's. So either it used to work, or it just doesn't work.
Or it might be the other call side of run a future is more helpful, or like it is maybe more helpful to think through this, because I think that this call site was written first, which is just saying set a timer if it's in the future. And for that concept, it does make some sense if you're trying not to rely too much on Bane, or it might be that Bane maybe rejected timers for the past. Actually, that's possible. I wouldn't be surprised if there was an era where Bane rejected timers for the past.
Yeah.
And so you wouldn't be able to set a time for the past, and so you need to give it now or something like that.
Okay.
Anyways, it's a bit of a mess. It never seems to, like, this code might misfire, but there's no bugs that come out of this because if you get an extra timer on accident, it's fine.
Yeah.
There's no bugs that I've seen in a couple of years. Um, anyways, that's a bit of a mess, but that answers the question
Maybe what you said earlier is
what was
maybe what we
happening
said earlier,
here.
right? That we actually do want to just store a next wake if there is one, so we can be explicit about just store it in the state so we know whether there actually is a timer outstanding, as opposed to trying to be clever about it.
Right. Or it also might be reasonable to say, just don't cancel timers. It's fine.
That's another. Yeah. When do we set timers?
So suppose you make a warp request for 1 minute in the future on a local desk. You do want that to go off. You can actually you can do this in the dojo with hep read or whatever. Actually, probably with build file as well, right? You just give it a date 1 minute in the future.
I guess so.
And that
it's not a
thread
feature
will wait a little bit. It's it happens over the network sometimes when there's clock skew. If you end up if you request for now and it gets there, but they're 30 seconds behind you, then that can happen. But yeah.
Okay, that's arguably a feature.
Well, it's a feature that it actually gives you a response correctly. I mean,
right. I mean, the fact that it gives you a response despite clock skew is good. I don't know if that's the way I'd prefer to have that be architected.
Yeah.
Because typically what you want is please tell me now, as soon as you can, whatever you actually have at the moment. Not whatever your version of now is for me. Wait until then, and then give me the response.
Right. Yeah. But anyways, so knowing that gives us the answer to what rep is doing, which is it's for canceling timers. And so the question we were originally trying to ask was, in Wake, when could you ever hit this situation? Because for that to happen, you have to have a request with no subscribers. And the answer is, well, when you cancel a request, we go through and delete them from the sets. We don't go through and make sure that that anything that has an empty set is removed from the jug.
Do we ever remove them then?
Right here. So wake will get called.
Because we just don't put it back in.
Yeah.
We're building up a new one, and so because we just skip over the old one, when we see it, we're like, okay, don't do anything, just move to the next one. That's effectively deleting it.
Yes.
Because we're not. Okay. All right, that makes sense. That's fine because wake gets called enough. Yeah.
Right.
Maybe at any given time you might have maybe one or two empty things hanging around, but as soon as anything happens, they'll get cleared. That's fine.
Yeah. I wonder if cancel request might even. We don't call wake after that, but you could. Doesn't really need to. But yeah. Okay. So then now we have an actual subscription that we want to see if we can fill. So we call try fill sub, which is the big one. We'll just try to understand it without looking at that code yet. That's going to give us three things. It's going to give us a new forward cache because these subscriptions, of course, can use forward. It's going to give us potentially some cards to output. There's going to be warps, presumably, but they could also be timer cancels, and I don't know if there's anything else. Maybe aims requests even. And it's going to give us a possibly new copy of the subscription we asked about. So try-fill sub is specific to the actual subscription, to an individual subscription. If that's null, that means it got filled. You probably got some cards back. And 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 it shouldn't be re-added to the cult. If it's non-null, then that means it either still exists, didn't change, or it still exists but it changed. In which case you use that.
Okay.
So we got those responses, and so we say, okay, send cards. Send cards is, of course, just a mill. It just says use.
Yeah, send each of these cards on each of these ducts. Right?
Exactly. Yeah. And then we're gonna. So now
send all the cards to all.
Yeah. Right. Yeah. Yeah. Send all the cards to all the ducts. And then we say, okay, if we got a rove back, so if we didn't get a rove back, just recurse, which means you delete it from the cult. If we did get a rove back, then we turn it into a wove by putting the person that it's for on the front. And we put that back into our cult. What? So we put it back into our cult, but we also right. Okay, so we put it back into our cult, but it's possible that the rove that we got back, and therefore the wove that we came up with, so that the request, it's possible that this modified the request, and further that it modified it to be exactly equal to something that was already in the cult. You can tell there must have been some nasty bug here, because if like the way that you would naturally do this is just duck.i.subs, ducks.i.subs, which would say, okay, just put it back in the cult under its new name. But if there was something there with its name already, then you need to merge the old and the new requests.
Okay, so this is a sort of concrete example of something we were talking about and then the first one, I think, right? We're one of these discussions where we were saying like the way that Clay, I think you had mentioned this, that like the way that Clay kind of takes in a new request and then says, I can sort of link this up with this other existing request. Right. But then like that request itself can change over time. That seems sort of prone to error. And it does seem like this, probably did have an error here at some point. Mm-hmm. And it's a little hard it's hard for me to understand as I'm hearing it and reading it. Like I get what you're saying. Like, okay, we need to somehow unify this request with this other request, and it might be changed by virtue of having fulfilled it. And like, man, this is it's a little tough.
Yeah, I think like if you think of it as a really shouldn't be a put by, it should be more like a put Jew. Except not a put Jew because it's several of them. So I guess it's a gas Jew, but that's awkward to deal with, basically.
So you're adding to the value in a map from something to set of values. So you're adding a new list of values to that list, to that set.
Yeah, you're trying to say, okay, all these subscriptions, I want to add it to the cult at this request, and I don't care if that request exists already or it doesn't. I just want to add these to it. Uni-Jew would actually be a reasonable way to do it, which is a new function next Arvo.
So basically, instead of okay.
Yeah, I mean, what it does is correct, though.
All right. Yeah, I feel like this is actually the first time that we've been going through Clay, and I'm looking at this and be like, I don't completely follow. Like, I mostly get it, but only sort of at a high level.
Do you mean these two lines specifically?
Well, this whole expression, the tis what clucks.
Okay, let's slow down a little bit on it then, because it isn't that hard to follow, and you never want your feet to leave the ground if you can help it.
Yeah.
Okay, so Quux is a cult. Means it's a map of wove to duct. We got potentially a new wove from Trifill Sub. So Trifill Sub tried to fill a subscription. It potentially changed that subscription somewhat. Either by, maybe a timer fired, and so now it has an eon for it, is one version of that, right? And it's like, oh, okay,
I see. Okay,
I can turn this from a date to an eon, but I already had someone that requested that eon. And so those were separate subscriptions before, because it was impossible for us to know that they should be the same one. Now they're the same one. And we don't know necessarily whether we combined with an existing one. And so somewhere along the line, we're going to need to check, does this new subscription match an existing subscription?
Right. And maybe it only matches an existing subscription now that we have an eon for it.
Right.
Yeah. Okay.
And so, so if we got a new version of this subscription, then we want to put into the cult at this subscription, which potentially already exists, both the ducks that we have and the ducks that might already exist in the cult at that request, at that wove. And so we get the ones that we have, which is ducks.i.subs, and we get the ones that already exist, which is we have a function for this now.
Yeah.
Probably easier to read. Where we say, so either there's actually you could probably, I think you can do get Jew here, and it's actually going to be even clearer. Let me see if it is. Is that in Zeus or Hoon? It's in Hoon or Jug? Yeah. Let's see. Yeah, that, because that gets us the whole set, right? Yeah. So we say take whatever already exists and merge it with what we had at ours and put that in the cult as the new set of subscriptions for that request, and then recurse.
Okay. Yeah, so it really is just unifying the subscribers, because because maybe there's already, now that this is potentially exactly equal to something that was already there may already have been subscribers there. Yeah.
Right.
Okay.
Yep.
Yeah, now it makes more sense as to why we're modifying these subscriptions over time too. And then it's basically like we're sort of unifying them as eagerly as possible. Like you can imagine just sort of not unifying them if they started off different, like this would work without this, right? It would work without kind of I think it would anyway.
Well,
we can't
need
it, but
by default it would clobber it. If you made this instead of like a map, you just made like a I don't know, a list or a queue or something, that would work. It would just end up potentially getting slow if you have a lot of requests for the same stuff, especially if those are expensive to calculate.
Right. Yeah, and so instead this unifies as quickly as possible. Like whenever anything changes, we check whether it became something else.
Right.
Then okay.
Yep.
Yeah, all right, this makes more sense now.
Cool.
It still does feel a little weird that we're sort of modifying the keys of this map over time as opposed to values. Right?
Well,
But I do understand it. Like
the
it does. It's sort
it's
of
kind of weird to even call it a map, because it's really more of a set with some like metadata that you don't want to put as part of the set. Because like the point of it being a map instead of um like a queue or something, because we almost always just either add something to this or iterate on it, is to deduplicate.
Okay.
Actually, even a list would be reasonable if you didn't care about deduplicating.
Because all
Yeah.
we ever do is traverse the whole thing. Like we never look at just one of them.
Yeah, you never looked something up by wove except for like here, which is in the process of deduplicating.
Right. Okay,
Yeah.
that's interesting. Yeah.
Yeah. Yeah. It's an unusual pattern of using maps or jugs or whatever that I don't know if I know of anywhere else that uses that pattern, but
Yeah, I mean, it
it
seemed
works
natural.
if you have the yeah,
Now that describe all the constraints, yeah.
right. All right, so that leaves us then with trifill sub, which has a smaller problem to deal with, which is just here's a subscription, here's who it's for, and give me a new version of that subscription, or null if you've filled it. Give me a list of cards that are required to fill it, for example, to give the actual subscription result. Which it occurs to me now probably are not gonna be timers, but if they are, then they're getting sent from every duct, which is fun. We'll see. And then a new copy of our Ford cache, of course.
Well, I mean, in sort of standard usage, we actually don't have any timers set for play, right? Like, we don't usually have a request for for something in the future at any given time, right?
I think that's correct. Yeah.
Okay.
Yeah. All right. So there's going to be a few different kinds of requests that can happen. We'll start by looking at sing. So let me make sure I'm on the right branch. I think I am. I just haven't paid enough attention. Yeah. Okay. So if we open up lol again, so that we can take a look at what these requests look like. There's a few different kinds of requests. We'll look at sing, which is the basic one, and then take a look at the other ones. Sing takes a mood, which is a char, case, and path. This is just a normal request. What we have in our state, this rove, is actually a little more than, well, for sing request, it's the same as the actual request. So rave is the kind of request you make from user space or from some other vein. Rove is the way that we store that internally, which might have some caches. We went over this in the data structures one. For sing, it's the same thing because there's no caches required. And so all we have is a char, case, and path. And we're saying, okay, now do we have an answer for this person or set of people?
Yeah.
Which, so if this is a foreign ship, so if ref is non-null, then like, so if it's a desk on a foreign ship, then we can check ha, which if you remember is our simple cache.
Yeah.
Which is, yeah, so if you make a request over the network and you get a response, if it's a simple request, then it'll go into here, and we'll just respond with that. We'll say, oh yes, we have that cache value, and so we're going to produce an unchanged forward cache. We're going to produce null for the unit rov because we've filled the subscription, so we don't need to keep any version of it. And then a list of cards, which is going to be just a single card. It's going to be a writ. Which takes, a possible answer to a request, mood being the request, cage being the answer. If the whole thing's null, that means we're giving a null answer, I guess, like as in your subscription has been canceled. Content of that being,
yeah, or just like there's no file there, right? Like, or a negative. Yes. It's a negative response. So yeah,
that's true. So for example, here we check to see if it was in the simple cache. If this is checking to see, says it was in the simple cache, but it's possible that what was in the simple cache was a null, in which case we produce null, saying you asked for something that took us a while to find out, but we have an answer for you. It doesn't exist. Our answer is no. Or we found the answer, in which case we will give you the answer, which is the main part, but we'll also let you know what the care case and path was. Specifically, that comes from what's stored in here, and I believe that can get rewritten to an aeon. So the date, or the version that comes back in here is likely, maybe always, going to be a specific eon instead of a date. So it might not be exactly the request you made, but it's going to be, potentially a normalized version of that. Writ, the only exciting part to it is, it's like, okay, we're gonna massage this into a riot by attaching the desk name and pretty much just the desk name onto it and reformat it slightly. And then there's this is the exciting part of it, which is if it's a local desk. So what sigref always means, if it's a local desk, then we give the response directly as a writ. If it is not a local desk, if it's a foreign desk, then we drip the response. Drip, of course, being you tell Bane, hey, set a timer for now. When the timer goes off, send this card, which means basically run this in a new event. Maybe the next event, maybe it'll be a soon event. Often the next event, not always. The reason to do that basically is, well, you want to give stuff synchronously when possible, because it lets you more easily be able to just like kill an event if something goes wrong. Like basically, you want to make as much stuff atomic as possible. But if it's a foreign desk, it often can't be atomic because you probably had to make a request across the network. And so in that case, it's not going to be atomic. You might have gotten a response immediately because maybe it was already in your cache, or for as we'll see later, maybe it's a request, or you kind of already saw before, where we already know the where it's before this limit date, so we already know the answer because we're fully synced to that desk. If that happens, then you could respond synchronously, but now you have this it becomes sort of visible to the outside and potentially a source of bugs, that sometimes foreign requests will come back synchronously in the same event, and sometimes they'll come out back in new events. And so testing the error handle, like your error handling code, is going to be rough because you have two separate paths that you need to test that you have no way of guaranteeing which one you're going to end up hitting, because it depends on whatever other things have made requests. It sort of makes visible this internal state of Clay of well, do you happen to have it in your cache already? Essentially, which is not good. So what we do is always drip it, so that the rule is if you make a request to a foreign ship, you're always going to get an answer in a new event.
I see. Okay. Yeah, the big reason to drip it is so that if we hear basically so that to make sure that nothing can crash the event that hears an AIMS response, right?
That's the
so
other
that we
reason.
can
Yeah, is
so like to make sure we actually
yeah.
do the act and don't just crash.
Right. Right. Yeah. You really don't like. You don't want it to be the case that a message going to a subscriber of Clay, if they crash when you hear about this, then that means first of all a negative ACK just going. Well, I don't even know if it can go on that kind of request, but like to the other ship, or wake can't proceed or something like that because it's crashing. Like that's not really acceptable. You really want to make sure that it's also notable that since these are separate drips, the each of the subscribers to a foreign desk are going to get their own event, even if they all got filled at once. Which is
That's interesting.
which I hadn't really realized until now.
Yeah, I'm not even sure we want it to be that way actually, because well, depending on what it is, if it's something where you want like multiple agents to be responding to it, you kind of want both of those to like update. I mean, ideally they would sort of both hear this at the same time, or you do some, which you can't really do, but you can sort of approximate that by doing like a two-phase commit type thing, right? Where like you tell both of them, hey, deal with this, but you can't emit any effects yet.
Right.
But then you notify them again, said, okay, you and everybody else who is supposed to hear about this has heard about it. Now you can go ahead and emit effects, and also read into each other's state. And so then by that point you can assume that if you emit an effect to some other agent that's also listening to this, that they'll also know, right?
Right.
Of course, that's like fairly heavy weight.
Yeah.
So it'd be nice to not have to do that.
Right.
But I don't know how else to sort of guarantee correctness in those sorts of situations, other than by just making it so that sort of user space apps, if they have that kind of need for collaboration, then they have to kind of just build it among themselves, which they can, right?
Yeah.
Like,
yeah.
there are different ways of doing that.
Yeah, it's worth monitoring that and seeing basically, do we end up building those a lot, like that kind of setup a lot? So far, I think the answer is no, but I wouldn't be surprised.
If we've had problems with this with breach handling.
Yeah,
that's where this has come up, which is
right.
Sort of only partially in user space, but it is partially in user space.
Yeah, but it's also it's much more likely that breach handling is going to need to be synchronized between agents or agents in the kernel or something than that something getting written to a file will need to be, I think. And further, the breach handling, arguably the answer is that this shouldn't need to be synchronized, and that our problem is that we're taking a bunch of stuff that used to be referentially transparent and then changing what a name means and what a name of a ship means, and that the real answer should be everything, that ship shouldn't be a pat p, it should be a pair of pat p and pat ud representing its rift. And so that way you would very rarely need to coordinate between different agents or between agents in the kernel about when this breach happens, because you'll know, are they talking about the old one or the new one? You can treat them separately.
It's true. Yeah.
Yeah.
Yeah, decreasing the requirement for synchronization is often the right way to go.
Yeah. I mean, we all know the problem with the Titanic. It had to sink. So Rit could produce either either something directly if it's domestic desk, or if it's foreign desk, it's always going to drip it. You get the response in a new event. This was a big problem before. This compromise solution has been only rarely comes up enough that it has to be explained, which I think is the ideal. Yeah. Okay, so back to we're trying to fill a subscription. It's a Sing subscription. If it was in the cache, we give it directly. If it's not in our simple cache, then we're going to try to read it out, see if it exists. But first thing to know whether we could even read it out is run case to eon, which we looked at last time, and is just, try to turn it into an eon if we can. If it's null, that means there is no eon associated with that, either because it's a date in the future or it's an eon in the future even, or it's a label that doesn't exist yet. If that's the case, then we can't do anything. So we're just going to produce the request as it is, no cards, no updates to forward. But if we do have an eon, then we can call read at eon, which is what we spent a bunch of time in last time, where we say, okay, go read according to what char it is, give us a response that is a unit cage, meaning either we don't have a response, or we have a response and it is no, or we have a response and it is this cage. And that might invoke forward, and so we call that updating the forward cache, giving us a value. If that value is null, that means we don't have the answer. If we don't have the answer and the eon is 0, that means we made a request for the 0th eons, which remember, the first time there's data in a desk is the first eon. The 0th eon is where there's no data in the desk, no files at all. And so we just print about that because it really shouldn't be happening. And every once in a while you'll see this printf, but it's mostly if you made a request for a ship that didn't exist, and then the ship exists later, and then your request to it goes through, and then they're like, oh, you made a request for a date before my first commit. I don't know what to do about it, which never really causes a problem, but good to have a printf for it, I guess. Otherwise,
I think you see this sometimes. Isn't that what you see sometimes if you try to ask for something that isn't public?
Possibly.
From some other ship. I think that's what shows up, yeah.
Yeah, well, because it's right. So read at eon, if you remember, if we don't get if we're not allowed to read it, because we've been threading through this for ship, right? If we're not allowed to read it, then we produce null, which is going to send us into this route. Yeah, that's a good point. You'll see either clay sing indirect data 0 or clay sing indirect data, depending on whether you know enough about the eon and so on. But yeah, that'll show up probably on the other ship. I feel like the one that you're requesting to, but
maybe
could be either. But yeah, so that's that path. It really shouldn't.
I just remember seeing this very
often, because the reason why this shouldn't really ever happen much is because we somehow know the eon, which we wouldn't know the eon if it was about something in the future.
Yeah, but line 1253, I think, is how this happens, right?
1253 is how you can hit this one, yes.
Yeah.
And the other way it can happen or right. So it can happen there, or it can happen because we did know the eon, but it was for a ship, like a desk we didn't have permissions to. Well, we really shouldn't have known the eon there. I don't know.
I mean, I've only seen this happen in development, and I think only
Yeah.
when trying to fetch data off some desk that hadn't been made public.
That's the main way it happens. I have seen it on the mainnet a couple times. It's it's unusual. The only real difference in here is if it is for the 0th eon, we just say, okay, even just forget about the request. If it's for another eon, then we keep the request around. But we don't know how to fill it. So hopefully it'll get filled by something at some point.
Yeah.
Oh, well. But that also gives an answer to why I've seen this in the, like, I'm thinking like a couple years ago now, where I would see this kind of repeatedly on the same ship, and I guess the answer is we don't delete the request, so it'll probably just then happen anytime you change that desk.
Yeah.
Yeah. Otherwise, so if value is not null, then that means we have the answer, or that the answer is no. And so we produce our current forward cache. We do not produce the request because we're filling the request. And we produce a list of cards, which is writ, as we saw before, which is the request and the value, or null if the answer is no. So that's what seeing does, which is reasonably straightforward.
Yeah, I mean, sort of zooming out on this, it's basically saying if we have this value cached, then produce it, which is basically like if we had just downloaded it, typically. And then otherwise, yeah, like check to see if we have like, an eon for this request now. Like if we can resolve this request to an eon, which presumably we have, and typically if something doesn't go weird, then we have data at this eon. And so go ahead and read the value, like perform the query at that eon, because Clay likes to perform queries at a particular eon. So now that we have an eon for it, we can do that. So perform the query, get the answer, and produce the answer, and keep the updated forward cache.
Yep, exactly. Yep. So that's seeing.
Cool.
Next and molt get handled together, which is a little bit confusing. But so, like, the historical reason for why these things are separate is I wrote next, and then I left the company. Someone else wrote molt at some point and merged them, and then I came back, and I don't know who wrote molt or whatever, and so really they should have been the same thing. There's a PR that makes it the same. Was it Ford Turbo needed? Okay, yeah. Because Next can only give
we don't need it anymore.
One result. But... Yeah, I think Gall still uses it.
Oh, that's right. Yeah.
It's kind of a like you really should be able to say, give me the next out of any of these, because you can't build that out of. You can't build, like, you can build next out of molt, but you can't build molt out of next, and so maybe molt is the correct one.
I see. Yeah.
And speaking of building the one out of the other, first thing we do here is we shadow rove by taking it. If it is a next, we rewrite it as a molt. What can you say?
I was going to say that the other way of thinking about this is, it's only Gall that uses this, I think, for agents, right? And so it knows exactly which agents it wants, and so you could just have a bunch of individual next requests.
It could, yeah. You kind of don't want to get a bunch of next responses if like one of their
Oh, that's
dependencies
true. You want all the
changed.
agents to update at the same
Right.
time. Yeah, you want an
Gall would
atomic
need
update.
to yeah deduplicate those.
Or we need to like collate them.
Yeah. Right.
Yeah. Okay. Yeah, that's a good point.
Yeah. Right. So this is like bad style, but it's right. So so rov is what everything else refers to as our request. We shadow that, but we tis-tar vor so that we can later on refer to it. But most everything we do by just looking at rov, which is guaranteed to be a molt. This is just converting a next to a molt in the obvious way. Like this is a set.
We're shadowing rov here.
We're shadowing rov, but we tis-tar it before that so that we can still refer to it.
All right.
This is also why we don't tis-dot it.
Yeah.
Yeah. And then we go into this recursion where we say, okay, so we have a mool, so we have a molt, which the contents of a molt are a mool, which is a case, so everything has to be at the same version, and then set of pair, case, and path. Sorry, care and path. So it's a bunch of care path requests, all at the same version. And specifically, molt's semantics are that you make a request at a particular case, and then you give a response when that case has, or sorry, when the contents have changed since that case. So
right.
if you make a request for now on, say, everything in the app directory, and then a commit comes in changing something in like the lib directory, or the docs directory or whatever, nothing happens. But if then another commit comes in, it changes one of the items in the app directory, then you'll get a response. So first thing we do, okay, so if rov, right, so the request that we get from the user just has a mool, but we keep some extra metadata around. Specifically, we keep the actual eon of the sort of beginning of this request. Once we know
that might have been some other case, right? It might have come in as like a date,
a date or a label, yeah.
Yeah, and then so we don't necessarily know the eon yet. So then maybe at some point later, that date resolves to an eon. Until then, the eon there is sig. But then,
yes,
once that does resolve, then we lock it down and stick it in the request here.
Exactly. Right. So that's all this is doing, is saying if the eon is sig, that means we don't know it yet. Maybe this is the first time we called wake with it, or maybe it was in the future or whatever. Then we say run case to eon, which we've seen before. If we still don't know it, then call store. We'll take a look at that in a second. Otherwise, we do know it, in which case we write it into our rov, write it into our request, and we null out these caches, which presumably were already null. We'll see if there's any, like we'll see later on if there's any chance for them to not be null originally. Let's take a look at store real quick to make sure we understand what's happening. So store is producing our unit rov and list cards, which unit rov is the possible response, which is always going to, like, there always is going to be one in this case, but that's just like, that's the response, that's the output that try fill sub wants, and potentially cards. So for
So then the response there really meaning like what are we transforming this request into, right? Like we're transforming it into a slightly different request, right?
Right. Yeah. So
By
so
updating some of the
right. All this is doing is saying basically if the original request was a molt, then just produce this, like just produce it. If it was a next, then massage it back to a next, which is a messed up way to do this stuff. It should just be like, I don't know, a flag in here or something that says whether your answer should be a next or a molt. Really, the answer is next and molt should be combined or whatever. But yeah, so this is just undoing, like this is where it's checking. So we say rov, of course, is a molt. It's always a molt. Vor, which is the alias we used for the original rov, if that's a molt, then we want to just leave it. Otherwise, we want to assert that there's one item in it and then turn it into a next. And it's
and stick the item in there.
A lot of boilerplate that really shouldn't be there, but it is there.
Yeah, makes sense.
Right. So back to where we called that was if we're trying to turn the case into an eon, we don't have an eon for it, just store it in our state. Meaning just no op, basically. Otherwise, modify rov to have notably, it's not the eon that the request was made at. It's one more than that, because it's the first eon that we want to try and see is this different than what it originally was. So eon there is the eon that we're checking now, not the eon that the request was made at. And it will potentially over time like increment, right? That's at the end of
it'll increment within this function, but the increment won't, the eon in the molt won't increment, will it? Or no, it will, because
it will.
If we checked it for change, like, all right, we checked it at,
right, like we're at version 5, and we know that like and this is says okay, yeah, they want next from now. Now is version 5, so we'll put it in here version 6. And then we're going to go through here, and it's going to be like, well, I can't do anything with version 6 because version 6 doesn't exist yet, and so we'll store that. And then version 6 comes in, but it doesn't finish the it doesn't finish the request. Then
it'll not finish the request.
It might go to 7, might go to 8 if nothing in that
if it hasn't
changed. Yeah, exactly.
Yeah. Right. So then. So this eon is basically the last checked eon in the cache, like in the molt.
It's
like in
the one that we want to check next.
Okay. All right.
Yeah. So this just says restart here. You could rearrange this so that it just fell through. With like a what cat instead of what sigs in various places. But so it's saying, okay, if we have an eon, just start back from the top and go into it and make sure that your caches are empty.
Sort of should be already, right?
I think so, unless there's some way that you can fall back into this, but I don't think there's a way to fall back into it.
Yeah. Okay.
I likely just got paranoid at some point. I was like, I don't know how this cache could not be empty. But it looks like there's something in the cache.
Yeah.
Right. Okay. So now we have an eon that we're looking for. So we have this concept of old cache and new cache. Old cache is the kind of reference. It's the version that was referred to as, this is like to tell me when it changes from this version. And so that's either going to be null or it's going to have some of our data, all of our data. I think it's always null or all of our data, but we'll see. Yeah, actually, that's wrong. It might have some of our data, or at least it's written as though it might have some of our data. So first thing we do is say, okay, let's try to fill in the old cache. First, we want to check, is the old cache complete? So complete is if the so we're given the old cache if it's non-null and every item in it is non-null, like has a non-null entry, then we consider that complete. So that implies an invariant that old cache needs to be either SIG or have all the relevant keys in it. And if you don't have any data for that, then that needs to be represented in its value, because its value is cache, which is unit cage, with the usual semantics for that. So if you ever end up with an old cache where the mult is asking for these 5 files, old cache only has 3 files in it, there's a bug somewhere. That's bad.
Okay, but it seems like we don't treat that as a bug necessarily. We call read unknown if that's the case, right?
No, if that happens, then we might errantly do stuff. We'll errantly consider it complete, even though we don't have all the data. And I don't know what's going to happen if that happens.
Wait, we will consider it complete? I thought the complete would say no, because it does a levy, right? And so, like, if you don't have values for some of those, then...
But it does a levy over tap by of have. So it's checking of the things you have.
Oh, okay. So that might just be missing some of the care and path pairs that are in the mul. But it's not checking that.
Right. It's not checking that you have all the keys. It's checking that you have any keys, and that for any of the keys you have, you know it. Also,
I see. Okay. So
yeah,
because this is just assuming that it works. So it's basically like if you have any of them, then we'll assume you have all of them. Yeah.
Yeah. Does that feel clear? Because it's like this cast is a TMI cast because
it's a lot clearer without the TMI stuff. Yeah.
Yeah.
Much clearer.
Yeah. Can almost do it in a single line now, but I don't know. It's important. I'll do it separate. Right. What I think should actually happen here is that we shouldn't have that invariant, and if it's null, it should not. It should just not be in the cache. But oh well. That's actually not that hard to change. Maybe I'll get around to doing it. Although it probably conflicts with Liam's PR. I should take a closer look at that one. It might just resolve this anyways. Oops. Okay, where were we? So, old cache. If the old cache is complete, according to our belief, then we don't need to do anything. We just, the old cache that we have, which represents the old cache.
Right. We don't need to build. We don't need to run a build. Yeah.
Right.
Yeah.
Otherwise, we want to try and read it. And we, just for fun, undo that increment and do it based on that instead of... we really should be able to just do this, I think. Assuming read unknown, how it works out. I think it does, but it might not. So let's see what read unknown looks like. So read unknown is we're given a mul and we're given the cache that we know about so far. And here we say if our cache so far is null, then we go ahead and fill in all the keys. Kind of an awkward thing to do. But we fill in all the keys with null as the contents.
Okay.
The fact that we have to do that is more evidence that it should just be. They should just, if they're not there, then they're not there. Like if they're not there, you interpret that as null. If they are there, it's unit cage instead of unit cage. Anyways, so we fill in all the keys, which is like that. That means we're always gonna hit our invariant unless something weird is happening elsewhere. Because we either had null or we put in all the keys. And this is the only thing that adds keys to it, I think. And then we recurse and we say, so this is the tree-wise recursion. I don't know why we do it tree-wise, but we do. And we say, for each one.
I guess this is before there was some like map function like run by or something.
Yeah, I think run by would be well. No, okay. Run by is not sufficient for this because we're threading the forward cache through it.
Yeah.
Yeah, you could do it with. I don't know. There's a few ways. Honestly, this is probably just like the cleanest way to do it with the functions we have right now.
Yeah, it's fine.
Yeah.
Yeah.
So we recurse tree-wise for each item. We check and see what's its contents in the cache. If it has contents in the cache already, we leave them as they are. If it does not, then we call a ver, which, if you remember, is the entry to sing requests. Like that's what scry calls. It's just you give it a mood and it'll give you a unit cage. Right. So we just say basically, okay, well then scry for it, and put that in this tree, and thread the forward cache through.
So, all right. So basically, what we're doing here is we fill in. We fill in everything with a sig.
Yeah.
And then we actually scry for each one.
Yeah, and get as many as we can, because a ver could give us an answer. It could give us an answer that is no, and it could give us no answer. It could just give us null. In which case, our cache would still be not complete, if that's true for any of them.
Yeah, okay. And so basically this is... Oh, it could still be a null.
Right.
So Q here is unit cage.
Yes. It's that.
And that's also a cache. Yeah, right. Okay.
Yeah.
And so right, if we have this, if we run this before and we have a cache and it's in the have that we passed in here, then we use that. Otherwise, we try to run it. Yeah, and we try to fill in all the blanks. Okay.
Right.
And so what comes out of this has potentially some SIGs in it, either from not being able to run a query at the current eon.
Right.
But
if it has some mix of SIGs and not SIGs, we know that we won't run the not SIGs again. So it's like performance wise, it's gonna run these until it gets an answer and like for each one.
Yeah.
And then it'll keep.
And this is looking into
it finally fills up.
Right, and it's hooking into the forward cache with the forward cache promotion, right, in such a way that like if we do a commit and forward, like it'll quickly know that no dependencies have changed if none of them have changed.
Right.
Yeah.
Right.
Okay.
Yeah. So that fills in the blanks as well as it knows how to.
And I think that function could be shorter, right? Like it's probably efficient to do this tree-based recursion, but if you just, tapped this out to a list and then turned over it and then
Well, you can't turn over it, but
not turn, but
yeah, you
just
do
did
naive
over.
recursion over it or something.
Yeah.
Yeah. It would be a couple lines shorter. It would potentially have more reason, like better names. All of this would be significantly simpler, and we've seen this in earlier code as well. If you had some way of tis dotting two things, right? Because that's all that this is doing, right? This really should be something like l.have and fod.dom is those two things, and then you also get rid of this line. You also get rid of this line. I feel like I remember
for this.
Yeah, I forgot what it was though.
Yeah, destructuring assignment
Into tis dots.
Yeah. Yes, you could tis dot into like arbitrarily shaped noun. Yeah.
Yeah. I mean, yeah, that would make this kind of code like it's hard to get a proposal like that through because people don't ever see this kind of code usually. But when you do run into this kind of code, you're like, oh man, that would be really nice and it'd be very natural and it would make something like this that isn't that complicated much simpler because it would look a lot more just like that.
Yeah, there are occasional cases where it would help a lot, and then you don't hit that too often, but you do hit them sometimes.
Right. I doubt people would really abuse that feature. I don't know. They might.
Yeah, I don't know how you'd go about abusing it exactly.
Yeah.
Probably, maybe you could. So I'm sure somebody will figure it out, but
people don't even abuse tis col, and that one would be probably even easier to abuse. But yeah.
I mean, the real one that you can abuse with and really shrink down your code with is tis hep, and people don't abuse it that much.
Yeah. Yeah, that's the virtues of making everyone sign their commits with their planet name, Just going to burn planets that use tis heps. Ban them from the...
I like tis hep.
There's a few tis heps. I wouldn't say that I like them as a class.
I only really like one line tis heps, but one line tis heps I think are quick.
Yeah. Yeah, there is a place for them. All right, so read unknown fills in the blanks best it knows how to, and so we are back here. We're saying if we already had old cache, don't do anything. If the old cache is not complete, fill in as many as you can. Make sure to do that at the right version. I'm nearly positive you could do that without that, but I'm not going to change this stuff. And then again, we need a destructuring tis dot or something to actually store that. And then we say, okay, let's find. So this is confusing. We're going to take a case to eon of something that we know is an eon. But if you remember, that's going to null it out if that's in the future, because even if it's already an eon, it's going to check whether it's beyond the current head of that desk. Sorry, that was here. So if it is in the future, just store what we have in the eon, which is potentially changed, right? Because this might have changed it, but go ahead and store that, and we're done. If otherwise, we know the eon of what we're going to, And so we're going to try and fill in its cache. So first we check whether the new cache is complete. If it is, produce that. Otherwise, fill in the blanks on that one.
How would the new cache be complete? Like, when do we fill it in here? And so we could fill it in here, but
there's a recursion that might make it possible. No, because the recursion clears it out.
No, if we go back to this, like it says, if new isn't complete, try filling the gaps. So basically, the oh yeah. So basically, we could call read unknown, overwrite the new cache with something, but it's still not complete.
Wait, sorry. Is your question about this check or about this check? Oops.
I think I understand it now. It's just basically like, yeah, if new is complete, then we use it. If it's not, then we try to build it or fulfill the queries. And then we check, like, okay, and we overwrite the new cache with whatever we built, which may or may not be complete.
Right.
If it is complete, then great, we're done. But if it's not, then like we could run this again, and we could have something in the cache, but that cache would not be complete.
Right. Yeah.
We could run it again, like up next EN. Yeah.
Yeah. Although notably on the next Eon, we do end up, and this stuff all got it got changed during software distribution and then changed back, and I got real confused. But I believe the answer is whenever we go to the next Eon. I think that only happens here, and we do clear the new cache on it, which is, I believe, correct, because the answer might be different. But we can walk through the code and see if we can understand that.
Yeah.
Yeah.
Okay.
Because there were definitely some bugs here that we fixed some of them during software distribution stuff. Right in that last sprint, it was literally like the day, like that however many hour on the meeting day, we were like, oh man, there's bugs here. And I remember how many of those got merged, but the deployment went all right.
I thought we merged all of them, but yeah.
Maybe I don't think we merged some of the moon fixes. I think there's potentially still issues if you cycle keys on your moons. If you just breach your moons, you're fine. If you cycle keys on your moon, I don't know, man.
Okay.
But anyways, right. So this is saying if it's not complete, if new is not complete, just store that. There's nothing more we can do at this point. There's potentially an issue there where you might get to the point where something can never become complete if you have a situation where basically where you run forward through these too fast and you can't. If you can't get complete stepwise, then you may not be able to keep going forward. And generally right now we always do get complete stepwise because basically wait gets called often enough. But the situation where that could not happen would be if wake for some reason wasn't called on every event, or if you got rid of this cache because you're like, it's cache, I can just get rid of it. Forward won't let you build stuff from the past necessarily. And so it might then just be incomplete forever, because it's like, it's forever going to be in the past, and Ford doesn't know how to build it. And so it's going to give you null, because it can't say the answer is no. It can't give you the answer, so it's going to give you null. And then you're stuck. So,
yeah,
there are potentially some rough edges there. I need to take a look at Liam's code. He might have a solution for that, or it might have the same issue or whatever. But I don't know. I don't feel great about that state of affairs. Oh well.
Yeah, it's interesting. Well, it's kind of a complex. It's a difficult query to like answer properly, right? It's like a complex thing to ask.
Yeah. Yeah.
I continue to think that like while it's kind of nifty that we can that we can answer such a complex question, like maybe we shouldn't be, and maybe we should figure out a simpler question that we can be asking.
Yeah, potentially.
Right? Something like, hey, can you build me all the apps on this desk? Right? But just like ask by desk, and then maybe there's like a flag for because like I don't think that this API is like particularly broadly useful. I could be wrong, but I feel like this is basically only useful for Gall, for building agents. And so like
Yeah,
I
mostly.
don't know, maybe that's
I mean,
yeah.
part of the reason it's not broadly useful is because it's not broadly functional. Like Molt doesn't work over the network, which is where it'd be kind of a convenient place for it to work, probably. But since it has never really worked over the network,
Maybe I don't know if that's how I'd want things to work over the network. Because
maybe
like
I don't know.
because it's kind of tying things together a lot. I don't know. It's introducing like a complex responsibility over that. Like I prefer network stuff to just be like, hey, give me the source for the next eon. Actually, not even that. Just give me the source for this eon, like for this particular eon, which may not exist yet. But like, right? Like I feel like keeping the network queries very like tightly scoped is gonna help a lot, and make them easy to scry. Right? You can't really scry for this unless the whole thing happened in the past. And even if you
Yeah.
can, then you can answer that scry, but it's still a little weird because like it's a scry that can sort of only be answered fully in the future.
I mean, there's
Which
an
is still
argument
legitimate. It's just,
that yeah, that next should be a care or even another dimension along all the cares, but like make it scryable. I don't know. It depends. Yeah, you can double
yeah,
down onto next/molt, or you can say they're not worth it. And I wouldn't double
right. I
down
mean, I do
right
think that
now. I might be convinced to cut them. Yeah.
yeah, I mean, it's worth considering doubling down too because it is like it is a seems like kind of a powerful thing to be able to answer.
Yeah.
I just don't know. Um, yeah, I don't know. Like when else you'd want to. I guess if you wanted to say, hey, when's the next change to something? Even if you're just doing sort of looking at the history of some file, right? And you were like, when was the next time this file was changed? That's a useful query to ask, even if it's
Yeah. I
in the
mean,
past.
and you could imagine extending that, right, by saying, okay, not only this file, but I want to construct a request that it's actually going to run through a mark conversion that like summarizes it in
Yeah,
some way, right? And I only care about particular kinds of changes, and so I'm writing this mark conversion such that it's only going to change if the way that I care about it matters. Like you could build a whole
right.
ideology out of this if you want. Like it's yeah, I don't know. It is a very powerful kind of request to be able to make as a separate dimension from cares and cases and everything. Um, I don't know. Maybe that's
I
too
think that
far.
yeah. Well, I think that the other way of the other way that I can think of asking this kind of question is based on the publication model that we came up with at the offsite, right? Which is basically like so for each you know desk build of agents, let's say, right, that Gall cares about from Clay. Clay could expose a publication, right, where it's like, at each, um, uh, um, every time there's a commit on the desk, Clay knows to like at least try to apply a diff to that publication, and there might not end up being one if like the builds don't change, right?
Right.
But it at least knows to check, and so then basically, instead of Gall directly asking Clay for the build of at some yeah at some eon, uh, there's a that subscription, that publication has its own sequence number, and so Gall is just subscribed to that, and so it's effectively asking for the next, for trying to just asking for sequence number plus 1 compared to what it just heard. And then Clay will only answer that when it has it.
Right.
And then for a subscription like that that's only in the past, like that could sort of ping pong back and forth many times in the same event until the whole thing completes.
Yeah.
Something like that. I don't know. That's like, there are downsides to that approach, because you have to kind of you have to create this publication object. You have this separate sort of sequence number that you're asking about.
Right.
And it's not clear that it would help that much with this kind of logic here, right? Like, would it actually simplify it? But I think it would simplify it a little bit, because I think you wouldn't be worrying so much about these kind of well, are these things present and not present? And you have all these different kind of bespoke sorts of requests.
Right.
So yeah, it would sort of move the complexity to a different area, which may or may not be a good idea. There may be other ways of framing that question too.
Right. Yeah, my guess is the answer is going to either be drop the idea of next and bolt and just use suck, right? Just use the eons have a there's a built-in to knock, the perfect function of this, which is increment. Or the answer is going to be that next should do something smaller, but that ties into the ability to do some kind of really generic, like that publication stuff we were talking about. You can build an index on this and you'll get told when the index changes or when the index tells you to tell or something like that. Which is going to make it more powerful even than what exists, but the code in Clay is actually probably going to be less than what exists, or at least the code in this part of Clay. I don't know.
Right. Yeah.
Yeah. So where we were at was we filled in the old cache, filled in the new cache to the degree that we could. If the new cache is not complete, then we short circuit. We actually don't short circuit if the old cache is not complete. So we could get to a situation where where the new cache is complete, but the old cache is not complete. If that's true, the way you get into the situation is if you do like a forward request in the past where forward can't build it, and so we're getting a bunch of nulls for the old cache, but we are able to get one for the present, which is strange, but it can happen. If it does happen, then we go ahead and say, okay, I can't guarantee that this is actually different, but I'm going to give you an answer anyways. So we respond by saying for each one, if it's in the new cache, which surely it's in the new cache, otherwise why was it considered complete? But so assuming it's in the new cache, give that as an answer. So just respond if you have the new cache but not the old cache. Respond, of course, is doing something similar to store, where like the whole point is to paper over next and molt, which is to say if it's a next, then we assert there's only one response because next only has one item, and we produce a writ with it. If it's a molt, then we go ahead and find its, the version at its top. Actually, because I guess we must end up giving date, apparently ris ris apparently always is going to give you the date of the response, because someone at some point needed that. We don't need that anymore, but so
that was also for turbo. Yeah.
Okay, yeah. So we find out what the date is, and then we put the care. Well, we take a couple items out of the moods, put them in res, give the response. Basically, what's happening here is molt. We're accumulating all these results, but we're not giving in the results. We're only giving a reference to which care and paths changed. There's no cage in here. If it's a next, then we are giving a cage. We had to calculate the cages, of course, to get this far, but RIS doesn't produce them because you probably don't care about them, and if you do, I guess you can scry them out or whatever. And this duplicates the drip or give, if it's a foreign desk drip, otherwise give. So
I feel like there should be a RIS gate next to the RIT gate to keep that pattern.
I think the real answer there is RIS should just be a kind of RIT. RIT already gives, like is riot, is unit rant. Rant is, I don't know. You can argue either way, but there's a cage there. This is anything in a cage.
Yeah, kind of like unify the next and mult. I'd probably just basically get rid of next and just use mult. Next is a pretty easy subcase of mult.
Yeah.
And then, but I was just thinking about like the code patterns of like, we have a RIT function there, and like it does the same thing as the
Oh yeah.
Slip versus give, and
yeah,
it'd be good to just have that be kind of parallel.
Yeah, that's true.
Symmetric. Yeah.
Yeah. I guess whenever we looked at case to date, I assume that's as simple as it feels like it would be. If it's already a date, use it. Otherwise, find the eon that it's at. It's probably an eon, but it could be a label. If there is no exciting, if there is, like, if it is a request, for example, for an eon in the future or a label that doesn't exist, we produce 0 as a date. Or if that eon is 0, then we also produce 0 as a date. Otherwise, we produce the date that commit happened. Oh well.
Okay.
Okay, so where we were at was we have the new cache, don't have the old cache, so we're going to go ahead and respond with all the data that's in the new cache. Otherwise, we have the new cache and the old cache. Both are complete. And we want to choose what we're going to respond with. Once we finish that, so this is a big long tisfaz, and then we just say respond with those changes if it's not null. If it is null, then we are going to so null would mean we had the old cache, we had the new cache, we had contents for each of these, but they're just all the same. Nothing that he requested changed, even though it's a new revision, because it was like a different directory or something that changed. And so if that happens, then we say, okay, well, try the next eon and clear out the new cache because it's a new eon. And if we have the eon immediately, we'll run through that. Otherwise, we'll get stuck on the case to eon, otherwise we'll get stuck on the new creating the new cache. And so we will just store it at its current eon and keep going.
Yeah.
Actually, we'll get stuck here. if we don't have that eon yet. But yeah, if we do have the eon but don't have the contents, it looks stuck there.
Okay.
So that leaves
This last case here, where both are complete. Yeah. Okay. So we check if anything has changed. If something has changed, then we send the responses, and that kills this thing, right? We're like, okay, we're done with the mult.
Yes.
Yeah. But otherwise, yeah. But if there were no changes, then we just try again at the same eon. But right now, we try it right now, which generally
at the next eon, yeah.
Yeah. Right. Yeah. But I mean, we don't defer this computation, right? Synchronously, we try.
Yes.
But we try at the next eon. Yeah. Right. Okay.
Yeah, because it could be, for example, that we just got an update from a foreign ship that told us the next 5 eons in a row. And then we're just like, oh, well, then I'll run through as many as I can.
Right. Yeah. Okay.
Yeah. So that leaves us then with the last section of the next mult handling is recognizing if anything changed. So we roll over the old cache. So these are going to be all the cache values. So for every item in the old cache, and we're building up this list of changes, right? Map of mood, which is char, case, and path to values.
Yeah.
Where if that's null, that means... So if it's not in the map, that means it didn't change. If it's in the map, I believe that means that it changed and is now null. And if it's in the map and it's not null, then it's changed and this is the new value.
Yeah. Okay.
So we're building up that. This is the stuff in the old cache. We say, okay, is there something in the new cache at that same char and path? There better be, because we're asserting it. But there also better be because we already checked that they're both complete. So hopefully yes. So now we have stuff from the old cache. So we have the old cache value, new cache value. Really long name, but I think I was just really confused about what was happening here, and so I gave it a really long name. Oh well. It is hard to read with that long of a name, though. So we assert that they're not.
You could cut the values off and read it that way.
Yeah. Yeah.
Unless those are data. It should be, there's old cache.raw, but that's not the same thing.
Yeah. Even new and old are probably fine. I don't know what it was before. It was probably like
let's try
cache and shack or something. Okay, well, we can at the very least get rid of this.
Yeah.
Whoops. Yeah.
It's a lot better.
Yeah, new and old is maybe a step too far, maybe not. There's also new entry, which is so new cache, old cache. That'll work. Okay, so so let me decompose this in my mind. So if old cache is null, new cache is null. If either of them are null, then
we got a problem.
Assert not either of them are null. Yes, yeah, exactly. So, right, because that means it wasn't complete. Should have been complete.
Yeah.
Okay. Then we're gonna say, let's see if there's a new entry. If there is no new entry, don't do anything with it. If there is a new entry, put it in changes. So this is producing a unit. If that unit is null, that means no change. That means it doesn't even go into the map. If it's not null, then we're going to say what that change was, which could be to becoming null, but yeah. The mood is going to be described as our current, like that eon that we've been saving, that one that's been ratcheting forward until we get a change. So because we're going to want to give the answer and what mood or what version it was at. So we make a mood out of that with the char and path. And then we say, okay, so it does not exist here means it's not the outer unit, it's the inner unit. It means we know what the file is, but there's nothing there. Like the file is empty or whatever.
Right.
So if there's nothing in the new cache, then we actually go ahead and notify. That was a change that did happen with software distribution. It's questionable because what it really should do, arguably, is say, if it didn't exist before and now it doesn't exist, nothing's changed, and so I shouldn't say anything. The reason we don't do that is because it means that you don't get stack traces if you had an app that was crashing and then you make a commit and it's still crashing. Sorry, by crashing, I mean you have an app that fails to compile.
Yeah.
And you make a commit, it still fails to compile. You don't get stack traces in all the right places if you don't send another notification. And so,
yeah, which is a little odd, actually, right? Because the stack trace doesn't come back in the response.
Right. It comes back, like it gets logged out somewhere. I think. Arguably, what should happen is like sen A maybe should give an each of A's and a stack trace or something like that. But yeah, those stack traces are not in band enough,
right,
for it to work right. So instead, we just say, okay, if the new one is null, which in the case of like a forward build is usually means that it failed to compile, but there are other ways it could be null. Then we're going to go ahead and give a response. So molt doesn't really guarantee that you won't get a response too soon. Like it doesn't guarantee. It is really best effort. Like, if things don't change, then I might not give you an answer, but I might give you an answer anyways. Oh well. It's not great. And it speaks a little bit to how powerful and how hard it is to implement that as an interface. And so maybe it's the wrong interface, or maybe we should just double down and get it right.
Yeah, I mean, like it's arguable whether you should be able to scry out builds. Like it's nifty, but for anything serious, you really don't want to do that. So.
Even if you're not scrying, though, you still some way or other. You do want to be able to get the. I mean, you need a stack trace and.
Yeah. Well, yeah, and the thing is that if you scry, then basically, that can fail. But the build could fail non-deterministically too. Which, I mean, I guess that's fine. You just that event just doesn't complete your performance scry.
If it fails non-deterministically, we're not going to hit any of this code. But there will be a stack trace that's somewhere we need to print. But yeah.
Yeah. Well, and you might want to still have like I mean, you might want to run the commit anyway and just say, hey, like, I did this commit, but like this build failed. And so here, I'll give you the results of that build failing. And if you're not Gall and you don't, crash on a failed build,
right,
then that could be okay.
Yeah.
We actually do want Gall to crash on a failed build, not run the commit, right? Like roll back the commit. But
yeah. Yeah. Okay. So if it doesn't exist in the new cache, then go ahead and notify. Otherwise, it does exist in the new cache. If it doesn't exist in the old cache, that means we added it. in which case we want to notify and tell them what the answer is. So it's u.new cache. Otherwise, it exists in the old cache and the new cache, and so we want to check: are they equivalent? Which equivalent means that their mark and values are the same. These are cages, so don't check the type. Yeah, exactly. But if their mark and value is the same, which is what we always check everywhere in Clay, and that's what goes in the hash and so on. If they're the same, then it's unchanged. Otherwise, it's changed. That's so just produce it.
Yeah.
Yeah, and so if you run through all those and nothing ever changed, nothing will ever get put into changes, and so we'll move on to the next eon. But if anything did, we'll respond. That'll clear it, and that's the end of next and molt.
All right.
Yeah.
Last one is many, right?
Last one's many. It is shorter.
This one's small. Yeah.
If we can do it in
this one says it's just as a sing over.
It's sing for send v.
Oh, okay.
If we can do this in exactly 30 minutes, then it'll be exactly as long as both of the previous episodes. So we'll see.
Okay, and if not, then we'll have to do some barbershop to round it out.
We'll just slow up the whole thing. Like either speed up or slow down the whole thing so they're all exactly 225.
Yeah, just some of it will be talking a little bit of Alvin and the Chipmunks or Darth Vader effect.
Exactly. All right, so.
All right, let's do it.
Many. Let's go back to where many gets like the introduction form for many happens in Deuce. So Deuce is worth understanding a little bit. It's related strongly to Wake. So start request is we just took a warp, right? Okay, so let's run this all the way back to the beginning. Warp. So we're in call. We got a warp. If it's null, we do cancel request, which we looked at briefly. Otherwise, we just start request. Okay, so we're starting a request for this ship at this rave. Rave is, of course, this. The first thing we do, actually, after checking whether this, if it's for a foreign ship, but it's not the kind of thing that we'll want to send over the network, then we reject it. Otherwise, we actually, do you want to run through that, or I forget if we talked about that already?
Uncapable? No, I don't think we haven't looked at this.
Right. Okay, yeah. So many requests you can always do over the network. The rest of these, basically, there's a whitelist of cares that we're willing to send over the network. We're not going to send code over the network. We're not going to send any forward stuff. We're not going to send anything from the miscellaneous scribe. We're not going to send someone our whole object store or something like that. What we will send is whether a file exists or not, like our current version number and the date that that's associated with, and then XYZ. So the data at a particular path, the directory listing at that path, and the hash there. Most there anything else. There might be one or two other things that should be on that list, but you want that to be like very much like a white list. Yeah. So that was called here. So So if it's not a foreign capable one and it's coming from a foreign ship, then we just print and don't do anything. Otherwise, we try to fill the subscription. Rave to rove is exactly as simple as you'd expect. We just say initialize caches and such to null. If we have that subscription, let's say go ahead and send any cards that it produces. Because remember, trifil sub is the one that we just spent all this time looking at, right? Wake is says trifil sub on all the existing subscriptions. So start request actually calls that before even putting it into our cult in the first place, which doesn't really need to do that. It could just put it in the cult and then call wake, but it does it this way. This would be faster. Okay. If you expect the answer to come immediately, then this is faster because you don't have to go through on average half the wake's going to go through everything. If you think you can get the answer immediately, then just doing that one directly is simpler and faster. But if you don't get the answer directly, then we call deuce, which is going to turn it into something that actually does get stored in our cult. And so this first thing it does is runs dedupe, which is longer than I expected.
Either we can turn this into something that we already have, right?
Right. Which
we went through this one before.
Yeah.
Pretty sure.
Yeah, you're right. We did. I think it was in the data structures one. Yeah, we did. So you check back at that one. It's basically saying it's probably even easier to read now. If it's essentially the same as something that already exists, then merge them. But by essentially the same, it's like this had a case, and this says that, and like it says a case labeled as a eon, and this one has it labeled as a label, and they end up all resolving to the same thing. Then you put them all in the same place. Not super interesting, but important to know that we do that. And then we say, go ahead and put. So this is put Jew, which means if it doesn't exist, put it in there with a singleton set of the current duct. If it does exist already, then add this to the existing set of subscribers for that wove.
Yeah.
Then we want to go ahead and do a couple of things. First, if it's local, so if it's a domestic desk, then there's not much to do. If we can't answer it right now, we just put it in there and we're done, basically. The only thing we do is we say, if we're waiting on a date, then we'll go ahead and set a timer for it.
Yeah.
Just run a future that we talked about near the beginning.
Right.
If it's a foreign one, then we actually need to do a little more. Main thing we need to do is send a request over the network so that we'll get a response and this thing will actually happen. First, we do rove to rave, which undoes what we did a second ago, because we're going to send this over the network. We'll skip this for a second, but that's actually the point of this diversion is to talk about this. But for the moment, we'll skip it just so we understand deuce more clearly. We say, okay, if we're making a request for something that they're not going to be able to give a response to, we're going to go ahead and crash so that just so that you get a notification of it now.
Yeah.
And so they don't ban us for asking for stuff we shouldn't. Otherwise, we want to make that request, and so we find the index from our so ref is a rind, so this is our request manager. We find the current index. We send over aims, that content, which we'll look at in just a second, and then we go ahead and update our rind by incrementing the index, putting what we're requesting into bomb.u.ref.
Yeah, so you basically track this outgoing request.
Right. That's all you're doing is just tracking the outgoing request so that you can cancel it if you need to, so that you know who to give the answer to when it comes back and so on. Send over aims is just making sure that we use the correct like wire format that's going to be expected when the answer comes back, the path that the foreign clay is going to see, and then we just emit a plea to Ames. It uses version 1 of RIF, which means which says don't send plops back. I'll ask for them, or blobs back. I'll ask for them individually. Yeah. So where did that come from? Right. So that's what Deuce is doing. It's just making that request over the network, which at some point we're going to look at when that response comes back, how that gets integrated into our state. But we've already seen how once it is in our state, we can give answers. Okay, so these lines here say if we're making a request to a foreign ship and that request is a senv, like it's a senv care, and it's a sing senv, so we're asking for a DOM over the network. You can't get a DOM over the network directly because we don't allow senvs on their own over the network. Then we convert it into a many request. And a many request is a request to get us sort of up to date. Tell us all the information required to have a complete cache of this desk locally, up to a certain revision. In this case, that revision is case.mood.rave, so it's the one that they were asking about.
What's an emote?
So moat is so it's
from, to, and path.
Right.
What's the from?
So we say we already know everything up to this revision. Let.dom, of course, is the top of the current desk, the top that we know about, right? So we say we already know up to here. Yeah, and we want to know it up to here, and this is the path that we care about, which is always FAS, basically. Then so we send that over the network and we start getting responses. So where we were looking at this is in trifil sub. We handled the sing case, the next and mold cases, and then we came to the many case. So this is the on the other ship now. We've heard of many probably over the network, and we want to start giving a response. And so we want to give an answer to them. Many actually, you might give several answers to them if you don't have all the information immediately. And so we want to get them up to date to the case that they asked for.
As close to it as possible. So if they ask for like cases 3 to 10, we only have up to case 8, then we give them 3 to 8 and remember to give them 9 when it comes in, and then 10 when it comes in, and then we'll be done. Is that right?
Exactly. Yeah. So the information we have is a moat primarily because it's let's see. All right, for many, what we have mainly is the track and the moat. Lobes is a cache there, I believe, something like that. So we start by saying, okay, you want to say from this revision to that revision. Have we even heard of the from revision? If we haven't, because it's like in the future or a label that doesn't exist or something, then we no op. We just say, okay, I'll tell you about it when something happens. Otherwise, we have heard of the from eon. Have we heard of the to eon? If we have heard of the to eon, then use that. Otherwise, just use our top eon. So get them as far as they can. Be 8 in the example you talked about. So that's how far that we're going to respond right now. Version is that came in when we thread the version number, or when we thread the ship's we also thread a version number through so that we know what version they used to request, so that we know how to format the response, what type of response to give. If there is, if it's a domestic request, then we assume send 1 because that's the top version. Definitely going to forget to change that when the version changes, but oh well. It doesn't really matter because menus never really happen locally. Then we want to check, okay, if like 2 eon is an eon that we know about, that's already guaranteed. And so we do lobes at path, which, lobes at path. Yeah, which is, so path virtually always is faz, but if it was not faz, then you could say, give me all the information, not for the whole desk, but only for the subdirectory. And this is just gonna check, like it's gonna go through all the data at that commit. Any of the paths that are not in that subdirectory, it's gonna ignore. Any of them that are in that subdirectory, it's gonna lop off the first couple of. I think it lops off. Yeah, I think the first couple of items in it, like up, because it's only getting the paths within that subdirectory. I think it's that class of thing at least. So it's saying, okay, this is the data edit. Don't even know that it gets used much, but it used to be really important. Does
that not get used at all?
It gets referred to here, but I'm not sure that it gets used at all anymore. It used to because Make Nako needed it, but Make Nako doesn't need it anymore. Well, let's get to here and see if it's necessary. So this line is
okay.
From mode.rov. Right. So we go ahead and update in the request that's in our state the from case to say it's now after our head. It's possible that it'll get deleted altogether. If we get done, then it'll get deleted altogether. But if it is staying around, we're about to update them with everything that we know already, and so we're going to rewrite their request to say that the from is from the revision after the current one. This is an example of how Wake could end up. If you had a many that started at version 5 and another many that started at version 7, and then as you start getting versions in, the 5 is going to go to 6, and then it's going to go to 7, and that's going to merge. That needs to merge with the other 7 that already existed, which is another case where
where
that Wake handling that might get triggered that we looked at in the beginning. But yeah, so here then we say, okay, what responses do we need to give? Okay, so apparently many only gives an answer if the data there actually changed instead of on every revision, which again, if you add faz, doesn't make a difference really. But if you're not at faz, then if you're looking for a subdirectory, it's going to give you a notification for every time anything in that subdirectory changed. And so that's what it appears to be doing, except that I don't think it's storing new lobes in, like it seems to be supposed to store them in there, and I just don't think it does. kind of want to make a note to remove lobes here because it doesn't appear to be necessary. But it doesn't fit in 80 characters, so...
Interesting. Why was that necessary? Why isn't it now?
So if the intended semantics is, because remember this predates next and molt, so there's a little bit of like a gesture in that direction of if you're making a request for a subdirectory and nothing in that subdirectory changed, even though there's a new eon, then we don't want to give a result, apparently. And so to do that, you store a copy of what it was in the previous one, and then
So this is like old cache in molt.
Yeah, it's doing the same thing. It probably shouldn't. Many probably should only work at FAS, but that's what it's doing. Yeah.
Okay.
Which, okay, since it doesn't get stored anywhere, I'll delete it from here. But it really should get removed from here as well. Okay, so can't be else. Okay, so we have all the data we're interested in. Now we're trying to construct the response that we're going to send, presumably over the network. That is, if they are doing a tracking request, then we go ahead and produce null. So track the semantics of track are supposed to be that we'll give you a response for every item between from and to.
Okay.
But unless I missed something here, I don't think it's going to be doing that anymore. I know that worked at some point, but it feels like you like this line needs to happen after a check regarding track, because if track if track is on, this should only increment instead of jumping to the end, and it doesn't do that. So instead, it just gives a different answer, which is strange.
The answer gives us null.
The answer gives is a cage whose mark is null, whose type is the type of null, and whose value is null.
I seem to recall this being used in Ford Turbo also.
No, it's possible,
but I don't remember. Maybe that was something else, but I
kind of want
feel like I remember like send null response from Clay.
Yeah.
Does anything use track?
I don't think so anymore. Well,
yeah, I mean, it'd be nice to have something like track for Kiln, right? For ensuring that.
Yeah,
it'd be nice
actually,
to
Kiln does. Well, last I saw, the sync flow in Kiln had a flag for track, which makes it use track. Okay, yeah. So something does use.
I don't know
track,
if we use it,
but nobody ever uses that flag.
We don't even use sync anymore in Kiln. It exists,
not by default. It like I'll use it occasionally for like on a very bespoke basis, but yeah, it never happens unless someone types it in.
Yeah.
Manually.
I mean, the thing that would be nice to have from Kiln would be, say, something like, only execute one, every update in a row. Don't ever skip any, right? And there are cases where it'd be nice to ask it to do that, right? If certain like hairy upgrades where you want to be like, please hit this one, and then like do these in order. Don't skip them. Right?
Yeah. I think it's potentially reasonable to revive that feature, but it looks to me like it's not functioning currently.
Yeah.
Okay, so if we're not tracking, which is virtually always the case, then we're going to go ahead and make a knocko of, from that eon up to that eon and give that as a writ. Labeled with send W, just to keep you on your toes. You think it might be like a send V because that's what it got replaced with.
That's what he asked for.
Right. I believe what happened here is that W existed for this purpose, and then it's okay. So it started with XYZ, TUV W XYZ, right? So it started with XYZ, and then he added many. So then we had W there, and then he was like, "Oh, I want to be able to ask for a DOM," and so he did send V because he's working backwards, and then U for does it exist, right? And then T. But then at some point, someone was like, "Hey, we have TUVXYZ, and I need to add another char. I'll use W," and so they use W, and now W means two very different things. Either a response to many, or it means give me the version number and date of this version for whatever case you gave me. Which
well, this isn't that different from that, right? Like, it does have a case in it.
Well, it does have a case in it, and also everything else that's in a Nako. It has a map of Eon to Taco, a let, and a set of Yakis.
Oh, yeah, I see what you mean. Yeah. Oh, okay. Yeah. Right, because this is really like, this is just tagging the response that has the cage of the Nako in it. Yeah.
Right, because the response comes back as a writ, right? And a writ has a char in it. And so it's like, what's the char for a many? Well, many is technically outside the char system. It's uncarable or something. So it was like, well, we'll give it W. Oh, well.
It's careless, I think is the term.
Careless, yes. Sorry.
Yeah.
And so, yeah. Oh, well. Somehow it gets...
Call it send many. Yeah.
I actually think... See, foreign capable allows send W requests as sings. So I wonder what would happen if you did a send W request over the network. I don't know if I've ever tried that. Maybe I have.
I think Kiln does those.
Oh yeah, you're right. So there must be something along the way that is able to recognize. Oh yeah, I'm expecting a Nako response, or I'm expecting I think it's a CAS response, like the PAT-UD PAT-DA.
Yeah, it's probably just like the wire dispatching, I guess.
Yeah,
right?
It's got to be something like that. Yep.
Hope we don't ever ask for those two different things in the same, like same flow.
Why would you do that?
Yeah, what are you, like a weirdo? Yeah,
exactly. Right. So the actual content of what it produces is a Nako, which is I think we looked at this in the data structures section, but it's all the new commits by hash, like the commit numbers to hash, that mapping, the highest commit number that we have so far, and then the set of commits themselves. And then null, where there used to be that you'd send the blobs along with it, but we don't do that anymore. We have them ask for anything that they don't have already.
Right.
Yeah. So that's
the card.
Say again?
I was saying, so okay, so these are the cards.
Right.
These writs containing Nakos.
Yeah. Which is now just guaranteed to be a single card.
Okay.
That's just, I always forget how Snock works. It's this, right?
Yeah, but we want card there, not cards.
Right.
Yeah, Snock is just backwards cons.
Yeah, but I
Right?
always forget how backwards, right? It's like, oh,
Oh
so
wait,
then does that mean
it's
that the
not just
list goes
backward
first
cons.
or the
You put the you put the list first. Yeah, it's list and then element, and it sticks the
right?
element at the end of the list. So it's not exactly backward cons. Actually, it's like yeah, I don't know,
I mean, it's
convert con or something. Yeah,
it's append a singleton or I don't, yeah,
yeah, yeah.
yeah. Um, okay, so there's our card. Uh, if we don't know the full 2 eons, so if we haven't finished, then you can give the card, but it's going to be, but we just want to give, but we want to keep like store the request. Otherwise, we want to erase the request and also give them a writ saying, "Hey, okay,
We're done. Yeah,
this many is
terminating.
done." Yeah,
Yeah.
exactly.
Okay. All right. Well, that's sending many.
Yep, it is. So that's a bunch. That really covers this. It does not cover receiving foreign data. That's a relatively small one. Probably want to cover that next time. We're at 226 right now. It's right on time.
All right.
The that hopefully won't be a full episode. We'll see. It could be.
Yeah, Ford is probably its own.
And then Ford's probably his own episode. And then these, yeah, it looks like it'd probably be 7 or so episodes. She was about right.
Yeah.
All right. That's all that happens in subscriptions.
All right. Thanks for taking me through it.
I think that's kind of like you start to see some ugly code here, and then you start to see some really questionable code here, and then this starts to get better. Forward is pretty solid. Writing is it's decent. It's not terrible. Merges is
All
pretty
right.
good.
Yeah,
But
I think we could clean it up, but it's like structurally sound. Yeah.
But like I think we've gone through the worst of Clay, at least in terms of code quality and stuff.
All right. Well, we'll find out.
We'll find out. Yep. Alrighty. And I'll go ahead and stop recording.